Hello. Let's see. So we are Adam and Chris. We're cooking up proceduralism with deck.gl. Today we're going to talk about a new visual scripting tool we've made with deck.gl to build different kinds of creations that we make. And by the end, you'll hopefully see just how easy it can be to create projects and test variations with a tool like this. We believe this kind of like tooling, this kind of like creator tooling has allowed us to be a lot more creative and a lot faster than we've ever been before when we're trying all these different ideas. So we like this quote from Donald Glover or Charles Gambino, and we think it encapsulates our work pretty well. Being able to present dramatically different options and make quick decisions without regret along the way is incredibly important to the way we create. We want the ability to fail fast and not get too attached to one particular direction as we go. Now, as data practitioners, too, we often start with this nebulous data set that we've been given, and we try to discover stories from within. Maybe it's bottom up or top down. We have some research topic in our minds, right? We want to explore that. Then we want to be able to we want the ability to take and customize our explorations to surface the insights that we discover along the way into something presentable. Our work involves a lot of exploration, prototyping, iteration when you work with data. Being able to evolve a simple idea you have into some polished result usually means you're making many small changes to data quickly and repeatedly in order to construct reality. So to tackle this, we've made a visual scripting language for deck.gl. You can use it to construct all the steps that you would normally take when building visualizations, and use it to procedurally build workflows that are reusable and easily shareable. And we'll be covering why we made it, and are looking to get some feedback from you guys on if this is something you'd find useful too. So we broke this talk up to about like 3 sections. The first one, we're going to be talking about real-time feedback loops throughout tooling and throughout this tool, using data reactivity and why it's a good fit for something like Deck. Then we'll get into the framework we've created to construct different kinds of scripts visually, and using this like concept of procedurally defined visuals. And then we'll end it with a bit of a discussion about where we're going to go next on our mission to try to empower data practitioners to be more creative. So we're Adam and Chris. We're the visualization team at Joby Aviation, a company that is making an electric air taxi. And our team's primary function at this company is to tell stories with maps and data. Bit of history is we both used to work at Uber with a lot of the deck.gl folks, actually. Joby acquired the old team I was on, Uber Elevate, which was Uber's air taxi team. So we have a lot of experience building tools with Deck, and we've been using it for storytelling for a very long time.
So a big question we get a lot is, why does an aircraft company need to make a map? For a bit of reference, this is our air taxi. This version is powered by hydrogen. It's 100% zero emission. It's completely clean as it takes off. So at the end of the day, our company is selling a real product that interacts with the real world, and people need to understand what it is, why it's different than what you might be familiar with, like a helicopter, why it's interesting, why you should pay attention, and then also why there are lots of stakeholders in this world. So there's like regulators, there's air traffic controllers, there's community members who might care about noise pollution, there's investors. So we need to talk to these different groups and explain to them why this is something that they should support as well. So a big piece of us for maps are that maps are a way to kind of ground these stories in the real world, and using real data helps with credibility and helps people understand what the story is. So I'm sure these are familiar narratives to all of you, but that there's something about showing, let's say, a route map of potential skyports in someone's own city with landmarks that they might recognize that is really helpful to help set the standard and help you understand what it is that we're trying to focus on. So as an example, here's a map that we worked on last year. We actually flew from the Wall Street skyport. We took our air taxi across the country and actually flew it. but a lot of the communities in New York really care about noise. And so this is a visualization of data that Joby worked with NASA to capture what's called an acoustic hemisphere of both our aircraft, which is on the left, and then a standard light aircraft on the right, right? And this is a simulation that we ran that would say, okay, here's the noise that you would hear from JFK to downtown Manhattan with a light aircraft, and isn't it so awful? You get this awful chop, chop, chop. It's really terrible. Whereas the Joby, it's like rustling leaves when you go by. And so there are various ways that we've, as a company, have talked about this narrative, but this one in particular really resonated with a lot of folks. And it's so we tend to build these. Chris and I tend to build these for events where we're showing it off in person, as well as for a lot of social or kind of various different avenues where we're showing it off. And so it's the different narratives that people care about and the different stakeholders. This map was really interesting to work on, and we used a lot of different deck tools. You can see there's 3D layers, there's contours, there's saturation, there's like post-processing effects there. But it took weeks of feedback from working with the teams who own the data, conceptualizing, working with our stakeholders externally, et cetera, like lots of back and forth and a lot of iteration. And a lot of those people only have a small time window to work with us. So us being quick to respond to their feedback and push something out that we think helps tell the stories is really important. So there's something already, like our work is never truly finished. We just run out of time. So we have hard deadlines. We don't really have kind of a continual iteration process, right? So over the years, we also, like I said, we do a lot of these network maps, which is kind of showing off potential in the future and where do we want to go. So we'll often start with either a consistent idea that we do over and over, or we have, like Chris said, a nebulous data set and not really know much about the data, but want to pull it into something like Kepler, mess around with it, try something and do transformations. And it tends to be a pretty consistent procedural process. It's a nice little representation of you have your inputs, you apply your transformation, then you've got your outputs, right? But oftentimes that transformation in the middle is pretty consistent. The inputs change and maybe the layers you choose change. So we love Kepler and how that works, but we call that a destructive workflow because like Photoshop or something, you're applying, you're drawing things on and you're layering things to a result at the end. But oftentimes, if you want to go back and change something about the earlier data, you got to go back in and reapply all these layers individually, right? And so you start to reach for automation. Maybe you either write a bespoke application and get really down that path, or you go for more of a notebook route. And a notebook has a lot of flexibility there, but it's also a notebook can be kind of complicated to when you've got dozens and hundreds of files that are all basically the same, just slightly different. So it's kind of an organization problem. Like Kepler is really good for these kind of one-off maps, and a lot of these things that we do are either a one-off or we'll come back and revisit them. So want to talk about the node or the framework that we made, which attempts to tackle this, and we call it nodes. So it's a way to build a deck.gl map visually. And it's web-based, it's web native in the browser. And we're going to talk through what we built and try to get some feedback here.
So this is a node. We call this an operator. On the left side, it's got inputs and it's got outputs. The outputs are on the right side. And then the UI for the operators are inside of the operator itself. This is a path layer operator. If you're familiar with path layer and deck, you've got all the props on the left as inputs, and the output will be that layer. You can add operators by right-clicking on this infinite canvas we've got. All these blocks are like primitive building blocks that you can use to build up a visualization, like numbers and colors. We've got dozens of different types of them. Each of them are performing a very specific composable task, like math or geospatial operations. And we've built it all on deck, so all the layers are there too, of course, like the arc layer operator. Notice that the inputs are color-coded as well to provide hints as to like what data types can connect to them. Green is like data, orange is color, red is a number, and so on. And you can connect operators together to pipe one operator's output into another operator's input. This is a color operator piped into an arc layer, and the operators like source and target color fields are both orange here. And we're reusing the same color for both the source and target color of this particular op. They're reusable as well and composable in this way. The data that flows through these operators is reactive, and the fields are all strongly typed. So the downstream operators, the ones on the right, run when the upstream data changes. You can see in this example, we're mapping mouse position to the latitude and longitude on the screen using an unproject operator, which is just a Web Mercator unproject function. And we can see whatever kind of is changing on the right side in that viewer op that we have. So you can also like kind of inspect your data along the way, sanity check, that kind of stuff. Let's bring it back to maps. Data flowing through these operators is arbitrary, and the operators themselves are composable. And so that allows you to do things where you can like pass a CSV of data points to a scatterplot layer, or even use the mouse position itself as a point on your scatterplot layer, and basically keep exploring these one-off objects and ideas here and interactively change the props along the way. What we're really focusing on with a application like this and kind of a paradigm like this is that interactively changing all the properties becomes this like first class idea throughout the whole experience. There's not a part of it that's locked away that you can't access, wishing it was there, wishing that input was there and that you wished you plumbed that to some UI, that kind of whole thing goes away here, and it allows you to instead build these applications up in this piecemeal fashion, where as you're going and discovering what you want to build along the way, there's an avenue for you to go that extra bit without jumping out of it.
So as a bit of a gauge, how many of you seen something like this before, or how many have used Blender?
No language that use graphs instead of code. I don't remember the name of it.
There's like Node-RED. I mean, there's, but like, it's used a lot in these like shader languages. So, we'll come back to this, but this is our, it's a little blurry here, but this is our representation under the hood. So we've got like operators are defined as a collection of inputs, these fields. And so the fields are what gives you the strong types. And field is just Zod transformations and Zod schema. Yeah. Big fan. Zod is great for this kind of thing. It gives us both type safety as well as some transformations. So there's both the high level types that we can connect as well as sort of a concrete representation that allows us to pass these around. But if you can see here, like with the deck layers are actually pretty simple. Like all we're doing is defining the schema, and then this is just giving us back a props object that then deck hands us. And then the output of this is a layer field, right? So it's just, and then fields are also reactive. So there's a way to connect them to each other. Right?
Okay, you probably can't read this, but this is your operator here, and it's got three main functions to it. One that creates inputs, the props, which are the fields, outputs, also fields, and this execute function, which executes every time new data comes in. And all this is doing, like you were saying, is it's constructing a deck layer here and returning it from the inputs. So yeah,
and then the next thing can take that deck layer. We use React Flow. It's a great nodes library there. There's versions for Vue and others as well. But one of the things we can do is we can add in widgets to make certain tasks easier, right? So it's not just these kind of generic components. We might have a geocoder component, which is like a very specific example. And this is just using Mapbox to geocode. And then we're piping into this directions API. We're using Google Transit for transit directions, and then Mapbox directions for driving directions. But this is fetching out to a foreign server and awaiting the result, and then when that's ready, it just executes downstream. But we then just pipe that into a trip layer. But it allows you to change that upstream value, right? And these are just two arbitrary geonodes that have been piped into directions, but maybe you want to pipe those into a scatter plot or whatever, right? You can then take those same values, just add in something in the middle, and then add some arbitrary downstream effect. And then the other thing to notice is the directions operator has, let's say, a latitude and longitude input, and that when you connect the upstream, that input goes away. So it's either basically uniform or like a value on the operator itself, or it's the value of the upstream that kind of assumes it. And then similar to Kepler, we really want to make it simple for you to get started. So if you drag in a file, we'll automatically create these layers and properties for you. And then the deck renderer is on the right where everything outputs to. So you can drag in, these layers. And
What is the file that you dragged in?
it's just
Is it like a saved version of this?
No, it's just a JSON of latitude and longitude points.
Yeah. Yep, it's similar to something you drag into Kepler to get started. I mean, so you can sort of think about this like this is all the stuff you get for free in Kepler, but then it's breaking apart for you. So this is like, there's more involved and more complicated than something like Kepler would be. So as much as possible, we're trying to like create these recipes that that you can get started quickly. But yeah, you drag in a file, we're able to detect the columns for you and then parse it out. And so we're really big fans of Kepler, and the idea is to kind of pull these closer together in the future. So we can look at an example here where these are two of the same files. So one of them is Skyports in Dubai, and one of them is Skyports in New York. And we can use this viewer operator to view the contents of each of these files. But when you drag these in, you've basically got the same logic for both of them. If we add in this switch operator, it allows us to use the index value to define what the downstream of that is going to be. And remember that only the data downstream actually affects, everything downstream is affected by the operator. Nothing upstream is affected, right? So you can still use the upstream values if you wanted, but with this switch operator, you're able to swap back and forth between the data sets. If we add in a bounding box operator, which is just looking at the extents of the latitude and longitude, we can then take that, pipe it into deck, which gives us a view state. And so previously, if you're swapping back and forth, you might have the data to the scatter plot, but like the camera's not shifting. Now we've created essentially a little script, a little program that is kind of arbitrary to the input and allows you to create something that all the downstream are going to use here. And again, we haven't mutated the upstream at all. We've kind of kept that available for you if you wanted to do something specific with that. But you're reading this kind of left to right, and then this logic becomes sort of encapsulated.
Yeah, so why do we do all this? Why do we have all this? And it really, for us, comes down to speed. Turnaround times are really paramount to us. We often get requests on very short notice, mostly through no fault of our stakeholders either. We just want to be able to respond quickly when people have requests with polished, high quality work. A typical example is someone will want a map as soon as possible. Yesterday actually, because a presentation's coming up and we got to have something cool. Being able to turn something around quickly that they'll love by their deadline is key to our team's success. We have these like repeatable, iterable processes in place to be able to respond quickly. And building tools like this, we find is really going to be taking down the time it takes to be able to do our job better there. But okay, so let's take this tool a step further. Let's say we want to add in some one-off elements, like an annotation to our map, or labels only on some of the points, like a highlight. This actually becomes really easy to accomplish visually. Deck has, the amazing catalog of layers it has, and we can leverage those to add labels with the text layer operator. We're getting these on the screen now. Dropped it in and hooked it up. We can take the position accessor and share it between the layers and use that to test, render the label. And then here, what we were just doing is we're putting in a editable table as well, because often when you want to do a one-off thing, you might have the CSV with like long table names, and you're like, okay, this looks great, except none of the labels are in the right place. They overlap with each other. They're too long. What would you typically do? You'd probably go into a text editor and, edit that CSV manually, drop it back into your code, refresh the page, drop it into Kepler, refresh that, and have to reconstruct all the logic in between to render that out. But now with something like an editable table, you can edit the values here and then flow those in through downstream and see the changes immediately. And then, oh, by the way, like another thing we did here is we were like, okay, these are still overlapping, so we need an offset column. So in here we added an offset column, dropped in a bunch of pixel offset values, X, Y, and then down here in the text layer, we added a pixel offset accessor, which simply parses that, and now you got your pixel offsets too. So with this kind of thing, you're able to not only bring your data in and work with it, but then you're also able to do those like very necessary one-off things that you have to do. And this kind of a tooling makes it very easy. One other bit that's in here is you can't really see it on the screen, but every single one of these operators has a little locking function on it. And when you lock the operator, it will no longer be affected by changes that are coming upstream. So when you make an edit to maybe the file, swapping out the file, it could just wipe out all your changes here. But because it's locked, it won't. So, just makes it pretty easy to kind of do that thing. And then like it should be very easy to then download this intermediate file and replace it if you want to do something with it, and so on. So for a more practical example, though, let's take a look at live ADS-B data for flights that are like flying overhead around the London area. For those that don't know, ADS-B data is basically like a live stream of all aircraft positions in the world in real time. There's cool websites you can go and get this data from. And so to pull this data, I've made a 1 second pulse with a time operator and some division operators. And I'm pulling the API with operator. And every second I'm going to be getting a new update of data. And so you can see the positions of the aircraft change every second. And then on top of that, you're able to go in here, and what I did here was I dropped in this filter operator, which can then let you go in and like filter out just to see the Airbuses or something like that. It's just flowing the data in through here. Then you can write a little bit of JavaScript in this kind of expression, and it just runs, data.filter on that data and then flows it downstream from there. I have another number of these use cases of a tool like this where you have both live data that you want to bring in and see, and also pre-recorded data that's in a file. You want the ability to be able to bring these things in and work with them at the same time. Because the operators are reactive and are just kind of doing what they do whenever something new comes in, that means that they're pretty agnostic to whether or not the data is live or pre-recorded. And because they're all asynchronous operators too, they're happy to wait, for that data to load before actually pushing that change downstream as well.
So this isn't a new idea. These are over 50 years old, and I have to imagine, the inspiration comes from a flow chart or from an E diagram or something, some circuit diagram. It's really the same principle. It's like thinking about these like components the way you would like on a circuit, right? So they're also used in a ton of creative software. It's really used a lot in architecture software. So this one on the lower left is called Grasshopper. It's a package for Rhino, which is a tool used by a lot of architects. And anytime you've seen any kind of crazy repeating pattern on a building, it was almost certainly designed in Rhino. It's like, the Bird's Nest, stadium, or any Calatrava bridges and things. They're built using this. It's in Blender. There's for Unreal, for Unity. Houdini is sort of the godfather of all these, and it's a big package used in a lot of visual effects for Hollywood movies. So water simulations, fire simulations, that sort of thing. And then there's Touch Designer and kind of these live performance tools. We've kind of tried to take inspiration from a lot of these, but also especially something like Touch Designer, which is really kind of incredible. The question we kept asking ourselves is, why is this used so often in this creative software? And I think I was talking to a few folks yesterday about this, but that it's this really nice happy medium of people who think artistically and creatively, and people who think very technically. That it's a very high impedance match with code and with kind of low level constructs, as well as this ability to get immediate feedback and an ability to iterate. And it also tends to work really well for these kind of declarative languages. So let's say shaders or SQL, right? And data visualization is sort of that happy medium between SQL and a shader language, right? It allows you to do these things non-destructively, right? So coming back to being able to change upstream values and have all the downstream effects apply, as well as changing something downstream that doesn't impact the upstream, right? So there tends to be two kind of worlds of this. There's either workflow processes. It's a lot of data stream tools use this kind of diagram. You're flowing from one way to the other, or you're describing this thing declaratively as a state of the world at the given moment, right? It allows you to keep your inputs and outputs relatively arbitrary, and then you focus on the logic that's in the middle. You can test a lot of ideas and all of these things. So this is the famous Kepler earthquakes example. This is earthquakes in California. It's just showing we can slap on some time filters, as well as a color scale in the middle there. This is more complicated than it needs to be right now. We're kind of still working out a lot of the patterns. We're trying to figure out exactly how we're using this and where do we want to invest in various components and whatnot. But one of the core pieces of this for us is not only this real-time interactive elements, but also the ability for any property to be keyframed. So similar to a Blender, similar to a Houdini, that any of these properties can be changed over time, which allows us to both interact with that live data, like Chris showed, the ADSB stuff, as well as offline things, or to have some kind of interactivity and really have a rich interaction. And so yeah, it's a kit of parts kind of at this point. The idea is that they're low-level primitives, but for things that we use a lot, let's say a color ramp or something, we want the ability to reuse those. So we're still very much in early development. Things aren't fully built out. This is a picture I took in Austria a few years ago.
Which is this summer as well.
Yeah.
Same.
Yeah. Beautiful drive, however, got to this vantage point. Said, I was supposed to see something here. So we're not quite there. There's things to build out. There's things that we want to do. But the fact of the matter is, there's 50 years of people working on this, and so people smarter than us have come up with really smart ideas for this. So hopefully there are things we can borrow from. But we're already really feeling like very productive in this tool, even with its rough edges. So we also don't expect to be able to build everything in nodes, and as developers ourselves, we don't really want to. Sometimes you want to drop down to code, or you're trying to parse or process some data set that you have. So in those cases, we have a code editor, and because it's 2024, it's got Copilot built in. But as you're typing, this viewer operator is updating, right? But you're getting suggestions based on your data set. You're able to process things really quickly here. So it's this nice iterative, interactive tool. You have the UI that you can pull out, but also you're still editing code like the capable developers we all are. So it also supports editing JSON, and this is where Copilot is really, really nice. So it makes editing lists of things really straightforward because it can guess things based on the context. We also have support for DuckDB, and as Kyle said, DuckDB is eating the world right now. So it's really incredible. There's so many things you can do with it. There's a world in which we'd love for DuckDB to underpin basically all the nodes and then have just one kind of final result, one final query at the end. But right now it's really powerful, and also all these values are reactive, right? So we can use mustache syntax, and actually DuckDB just announced support for variables, I think like yesterday. So you'd be able to assign, so we're doing string interpolation using mustache, like the handlebars, and it's referencing the values upstream. So when you add in the handlebars, it references other values. But so what this is showing at the beginning is typing in a new address that's updating the SQL. DuckDB is going and fetching that from the server. This is EV charging points all over Europe. This is some foreign API. And then we can use this switch to switch between layers and basically say, keep your data the same, but we want to show different things. So this isn't going to replace bespoke apps and certain things that notebooks are really good for. It's also probably not going to replace, but there are a lot of things where you really want to just spin up a simple tool, and you can either expose this UI with a custom thing. We could think about ways of only giving you access to the geocoder and then hiding all the logic in the back. But it's all in the browser, and it allows you to build these kind of one-off apps, which is pretty nice.
And animation remains super important for us as well. And so this framework we found pretty easy to extend in order to support all kinds of different animation use cases we have. Here's a slightly more advanced example where we have tons of different layers on the screen. And what we're doing here is we're basically clicking on the operators, and then on every single one of the operators, you have all those fields, right? Over here, you can go and click on a diamond, and you can add those fields down into this timeline and then change those values over time. And as you do that, you're basically constructing a video. This is basically a video editor for deck.gl now. And it allows you to, tweak those values, see the updates happen in real time. We're changing camera, we're changing radius, we can change colors, strokes, basically anything in Deck. You're just blasting out set prop updates. And Deck is very, very fast at being able to respond to those updates. And so it allows you to edit and preview these videos. And then we also are using things like Web Codecs, the new browser v4 encoding that's out there now, to then render these videos out in like 60 frames per second, 4K. There really isn't a lot of limit there anymore to the kind of quality you can get out of renders in the browser. And the animation doesn't have to only be about pre-processing animation. It can also be driven interactively too. So like here, we have a mouse moving back and forth on the screen, and that mouse is now what is changing the camera viewport. How we set that up is we put a switch operator in right here, and we have flowing into that switch like basically two bounding boxes, like two different camera positions. Those are the values that we're going to then blend between, and you can basically blend input to a switch as well if they're like numerical. So now we have a mouse operator flowing in through And that mouse operator is basically like indexing through the blend between these two inputs. You know, you could have keyframed this value as well, and then maybe built something with like scrolling and kind of driven that keyframe engine outside of this tool. But it just kind of shows you the power of this paradigm, where you're able to combine, predefined instructions and keyframes, as well as then pairing that with like interactive arbitrary input that people using the tool might be using. It's a very powerful system. With this kind of infinite canvas, you can zoom out and fork entire ideas really quickly and then switch between them and tweak the layer properties. So when you can, I find that when I can start to add and remove groups of nodes without a lot of friction anymore, I can try a bunch of ideas out. I can move forward with my favorite ideas. I can drop the things I didn't like as much and kind of show people like the 5 ways I was thinking about approaching this one problem. It's a kind of workflow that, again, like kind of Adam was saying, like tools before this that I've used to try to do this just don't quite fit right. It takes a lot of time to plumb these things together when it's in code. It takes a lot of time to organize my notebooks, when I've got like 3 or 4 different ideas and it's like V1, V2, V3 on my notebooks now. Git's not quite right either, because you're only ever looking at like one branched version at a time, and when you what you want to really do is you want to be in front of someone and show them 3 ideas almost at once, so this kind of an interface basically allows you to start doing this kind of interesting workflows. It's sort of like visual scripting, it's sort of like tool building, it's all kind of in the browser, and allows you to build these small programs visually, and I think that's one of the biggest aspects of this that I'm excited about. When you start to think this way and you start to think about non-destructive workflows too, you keep going back to this idea of like, okay, what I've got here actually is sort of like a recipe, right? It's something where you can add and remove the parts as you see fit as you go. There are also these things that can kind of be encapsulated. When we think of a recipe, you might want to swap out the pork for the tofu. You still have a delicious dish. It's just all the downstream stuff you do after that step is the same. But when you went in there and isolated that one part you wanted to change and just swap it out, you should just be able to do that kind of thing.
And it also makes it easy to share these workflows. So Comfy UI, which is a tool that people have built for stable diffusion and for these image diffusion editors, there's an entire ecosystem around people sharing these. So there's like ones for making stained glass, ones for slow motion video, retargeting, that sort of thing. I think this is, I don't know if I have the name of on here, but it basically says like you can upload your own dog here, right? But everyone else's thing downstream is the same. So if you could share around these little mini apps, how would that help people understand how Deck works, or make these kind of one-off things? Maybe it'd be a nice way to kind of extend out the way that the layer browser works for Deck, but share these things a little bit more. So just to wrap it up, we introduced a node-based reactive Deck framework for Deck. You can use it to create reusable recipes for processing data and sharing those out as tools, images, animations, or apps. It supports animation keyframes and a timeline. All properties are animatable. It supports data loaders, so APIs are no problem. And code and SQL operations with reactive pointers to access data from other operations. And finally, it's all web native, so you can write custom widgets in React like geocoders and color ramps. You can add in Waza modules, WebGL, WebGPU, pull things from foreign servers, whatever today's web platform can do for you. All right, so want to kind of throw it out. We need a name for this thing, so we're thinking Merlin in reference to Houdini, or Hubble 2.0, or Noodles, or there's a lot of things around spaghetti, or Gordian is like a Gordian knot. It's impossible, so you just cut it and call it a day. So anything like that that appeals, we'd love some feedback. But thanks for listening.
Are you going to open source it?
Hope so.
Yeah, it's not open source yet.
When? If enough people ask for it, then
it's pretty early in development.
Yeah.
Love to get the feedback if this is something you'd find useful. How might you use it? What would you want to use it for? That kind of stuff could influence our direction.